At 2:14 in the morning, nearly 50 Russian military vehicles were trapped on a narrow road leading out of Crimea. Fuel tankers stood beside ammunition trucks. Vehicles carrying Grad rockets, drone equipment, lithium batteries, and generators stretched into a convoy almost 1 kilometer long. A bridge lay ahead. Behind them, the line had become so crowded that there was almost no room to turn around. Above them, 18 Ukrainian drones were closing in from 2 different directions. Russian Pantsir S-1 and Tor M2 air defense systems were already in position, supported by anti-aircraft guns and electronic warfare units. The attack had been detected, but the crews had only seconds to decide what mattered more. Should they protect the bridge or defend the convoy? Then the first explosion erupted near the front of the column. Only moments later, flames burst through the fuel and ammunition trucks. This was not a random drone strike. The Russian convoy had arrived at exactly the right place, at exactly the right time, in a formation so tightly packed that only a handful of successful hits could produce damage far beyond the number of drones involved. But what forced dozens of military vehicles onto the same narrow route? How did Ukraine know exactly where they would appear? And did the Battle of Armyansk really begin at 2:14 that morning? Or had it actually started hours earlier with a completely different strike? Let's find out. Only in Military Force. Ukraine's operation was designed to do more than damage a bridge or destroy a convoy. Its deeper purpose was to influence how Russia moved supplies between Crimea and the southern front. By striking one key route first, Kyiv could force Moscow to rewrite transport schedules, redirect vehicles, and place greater pressure on the remaining crossings. Crimea remains a major rear area for Russian forces operating across Kherson, Zaporizhia, and southern Donetsk. Fuel, artillery shells, rockets, drone equipment, batteries, generators, and military vehicles must pass through a limited number of roads before reaching units closer to the front. That makes movement predictable, especially when one route suddenly becomes unavailable. It also means a local disruption can quickly affect several sectors across the theater. This is why the first strike mattered beyond the immediate damage. Ukraine did not need to locate every truck across the peninsula. It only needed to remove one important passage and watch where the traffic went next. Once vehicles were redirected, the supply network became more concentrated, slower, and easier to observe. The operation therefore followed the logic of battlefield shaping. Instead of reacting to Russian movements, Ukraine tried to create those movements. The first attack changed the map of available choices, while surveillance assets could track the result in real time. Each fuel tanker, ammunition carrier, and support truck that changed direction became part of a larger pattern. The strength of this approach came from Russia's dependence on fixed infrastructure. Bridges, highways, and narrow corridors cannot move when threatened. They also create schedules that must remain coordinated if frontline units are to receive supplies on time. When one route is removed, delays spread through the entire system. That concentration also reduced Russia's flexibility because every delayed vehicle increased pressure on the same roads, crews, and protective systems. That pressure can produce a chain reaction. Vehicles arrive at the same crossing, spacing becomes tighter, and commanders face a difficult choice between speed and security. Moving too slowly creates a larger target. Moving too quickly increases confusion and weakens control. Either way, the attacker gains a clearer picture of where the next concentration will form. Ukraine's apparent goal was to turn this pressure into a second opportunity. The first strike would not end the operation. It would prepare the conditions for another attack by forcing Russian logistics into a narrower space and a shorter decision window. In this model, destruction is only the opening move. The real advantage comes from controlling what the enemy must do afterward. To make that trap work, Ukraine first had to remove a route important enough to change the movement of the entire supply system. The chosen target was the Chonhar Bridge. Ukraine's first attack on the Chonhar Bridge was designed as a coordinated structural strike rather than a simple attempt to hit the roadway. The formation included 10 FP-2 attack drones and 4 heavier strike drones. The FP-2 aircraft carried warheads intended to damage key parts of the bridge, while the heavier platforms brought larger explosive loads for the deck and approaches. This division of labor mattered because a bridge is not destroyed like a truck or radar. A surface explosion may leave a crater, but the crossing can remain usable if the main structure survives. Ukraine therefore appears to have assigned different aircraft to different tasks. Some were meant to create broad blast damage, while others were intended to reach deeper and weaken the parts carrying the bridge's weight. This coordination allowed Ukraine to combine penetration, blast pressure, and target saturation within a single timed attack against the crossing. The drones crossed the steppe at an altitude of about 60 to 80 meters. Flying this low reduced the time Russian crews had to detect, identify, and engage the formation. It also kept the aircraft closer to ground clutter, where radar tracking can become more difficult than against targets moving overhead. Ukraine divided the force between two approach lines. That choice forced Russian operators to monitor bearings instead of concentrating on one compact group. The formation was shaping how the defense would react from the first warning. Two directions created more tracks, more decisions, and less time for coordination. Russian crews had to determine which group posed the greater danger, which targets were closest, and how firing channels should be assigned. The attack began placing pressure on the defense. The first Russian system to detect the formation was reportedly a Podlyot K-1 radar positioned southeast of the crossing. This radar specialized in finding low-flying targets that could be difficult for other systems to separate from terrain. Its role was to build the air picture and pass target information to the weapons that could respond. That information was then shared with a Panzer S-1 system and a Tor M2 battery around the bridge. Closer to the crossing, Zu-23-2 anti-aircraft guns provided a final layer of fire. The result was a defense built around several ranges and types of engagement. This arrangement gave Russia several opportunities to stop the raid. Guided missiles could attack the formation during its approach, while manually aimed guns could engage aircraft entering the final zone. Yet every layer depended on limited reaction time, limited firing channels, and the ability to move from one target to the next before the formation closed the distance. The most important feature of the Ukrainian plan was the way the warheads were matched to the bridge. The heavier drones were intended to tear open the road surface and damage the approaches. The FP-2 drones reportedly used delayed fuses, allowing each warhead to pass through the upper layer before exploding closer to joints, reinforcement, and load-bearing connections. This distinction was critical. A blast above the deck can lose much of its force into the air. An explosion inside or beneath the surface transfers more energy into concrete, steel, and the points holding the span together. That can turn several separate impacts into one structural failure. Ukraine also spread the intended strike points across different sections of the crossing. The mission did not depend on one perfect hit. Each surviving drone could contribute part of the required damage, making the attack more resilient if several aircraft were intercepted. Before these warheads could reach their assigned points, all 14 drones had to pass through 3 Russian defensive layers. Every second now carried greater weight. The next phase would become a race between a shrinking distance and a limited number of firing channels. Russian air defenses around Chonhar did not fail immediately. They detected the incoming formation, opened fire, and destroyed several drones before the aircraft reached the crossing. The Panzer S-1 reportedly engaged first, using radar and missiles to attack the leading targets as they approached from separate directions. This response reduced the strike package, but it did not remove the threat. Panzer could only track and engage a limited number of targets during the short window available. Every launch required detection, target assignment, guidance, and confirmation, while the remaining drones continued closing the distance. The system was performing its task, yet the attack kept more targets in the air than one defensive layer could manage. The Tor M2 then engaged drones that passed through the first layer. It provided another opportunity to reduce the formation before the surviving aircraft entered the final approach. Near the bridge, Zu-23-2 guns added fire against targets that had avoided the missile systems. According to the transcript, Russia destroyed 8 of the 14 drones. That result showed that the defense was active, coordinated, and capable of inflicting losses. It also showed that the Ukrainian formation did not pass through Chonhar without resistance. Russian crews succeeded in most individual engagements, and each interception removed one warhead from the attack. However, air defense is judged by more than the number of incoming weapons destroyed. Its primary mission was to keep the bridge operational. Once 6 drones survived, the question was no longer whether Russia had achieved a high interception rate. The question was whether the remaining warheads were sufficient to disable the target. Chonhar was a fixed structure with known dimensions and vulnerable sections. It could not move, disperse, or seek cover. This gave every surviving drone operational value. Even after losing more than half the formation, Ukraine still had enough aircraft to strike several critical points. 2 heavier drones reportedly hit the road surface and approach areas, creating blast damage. 4 FP-2 drones then targeted separate parts of the load-bearing structure. Their delayed fuses were intended to move the explosions beneath the upper surface, where the force could act against concrete, steel, joints, and supporting connections. The attack did not depend on one perfect impact. Damage was distributed across several points, allowing separate explosions to weaken the crossing in sequence. A bridge may survive one crater, but multiple damaged joints can reduce the strength of an entire span and make heavy military traffic unsafe. The battle revealed a central paradox of modern air defense. Russia won many engagements but still failed at the level that mattered most. 8 drones were destroyed, yet 6 reached the crossing and completed enough of the mission to put Chonhar out of service. This outcome also showed how saturation can overwhelm a defense without destroying its systems or preventing them from firing effectively. For Ukraine, the losses were acceptable because the surviving weapons achieved the operational objective. For Russia, the interception rate became less meaningful once the protected asset could no longer support regular movement. The decisive measure was not the percentage of drones shot down. It was whether the bridge remained open after the attack. Chonhar was now removed from the logistics network, but supplies still had to move toward Russian forces in the north. Fuel, ammunition, drone equipment, and military vehicles could not remain stored in Crimea. Moscow therefore had to redirect traffic toward Armyansk. That response was logical, necessary, and predictable. It also created the next opportunity Ukraine was preparing to exploit. Once Chonhar was no longer usable, Russian logistics traffic had to move toward Armyansk. Fuel tankers, ammunition trucks, vehicles carrying Grad rockets, drone equipment, lithium batteries, generators, and fiber optic cable were redirected toward the remaining road connection. This movement was not optional. Russian units operating farther north still required a steady flow of supplies, and the loss of one major crossing increased pressure on the alternative route. Armyansk therefore became more than a backup road. It became the main channel through which a range of military cargo had to pass. Ukraine did not attack as soon as the first vehicles appeared. Drone operators continued watching the road, tracking the arrival of each truck and measuring how the formation developed. This delay was important. An early strike might have destroyed several vehicles, but it would also have warned the rest of the convoy and allowed drivers to disperse before the route became crowded. According to the source material, about 50 vehicles eventually gathered on the 2-lane road before the bridge. The line stretched for nearly 1 kilometer. The lead vehicles were roughly 100 meters from the approach, while additional trucks continued pressing forward from behind. As the convoy grew, the spacing between vehicles began to shrink. Gaps that had reportedly been close to 60 meters fell toward 30 meters or less. That compression reduced the ability of drivers to turn, reverse, or create distance if an attack began. The cargo mix made the situation even more dangerous. Fuel tankers stood close to ammunition carriers and vehicles transporting rockets. Trucks carrying batteries, generators, and drone equipment were also positioned inside the same narrow formation. A strike against one vehicle could therefore create fire, blast pressure, or secondary explosions that affected several nearby targets. The convoy was becoming a connected hazard rather than a collection of separate trucks. Every additional vehicle increased the value of the target area and reduced the space available for emergency movement. That concentration shortened reaction time, complicated convoy control, and increased the chance that local damage would spread across nearby vehicles. The most important feature of the situation was that Ukraine did not need to search across Crimea for one large target. By removing Chonhar from the transport network, it created conditions that caused Russian logistics to concentrate at a predictable location. The road itself became part of the trap. Its limited width, the bridge approach, and the continued arrival of vehicles gradually produced the density Ukraine needed. Surveillance teams could observe the process, count the trucks, and wait until the convoy reached its most vulnerable form. This patience changed the nature of the operation. Ukraine was not simply reacting to traffic already on the road. It was allowing Russian supply requirements to assemble a more valuable target over time. The longer the convoy waited, the more difficult it became to disperse quickly, and the greater the risk that one explosion would spread through the line. By the time the formation stretched nearly 1 kilometer, the target had reached maximum value. The next challenge was far more demanding. Ukraine now had to strike the Armyansk crossing and the convoy within the same brief window, while both remained protected by Pantsir, Tor, and Russian electronic warfare systems. Ukraine's second strike used 18 drones divided into 2 groups. 8 aircraft carried warheads intended for the Armyansk bridge, while 10 others targeted vehicles inside the convoy. The 2 groups did not arrive together. The bridge formation appeared on Russian radar 30 to 40 seconds earlier, making the crossing seem like the threat. That timing was central. Pantsir S-1 and Tor M2 crews had to protect a route Russian logistics could not easily replace. Radar attention, ready missiles, and engagement time were therefore directed toward the first group. Every second spent tracking and firing reduced the time available to identify another formation approaching from a different direction. The attack was designed to shape Russian priorities before the convoy group entered the final phase. Ukraine did not need to destroy the air defenses. It only needed to make them commit resources early. Once Russian attention focused on the bridge group, 10 drones aimed at the convoy appeared from another direction. These aircraft reportedly used terminal control, allowing operators to view the target area through onboard cameras and adjust course during the final approach. That capability mattered because Russian electronic warfare remained active. The R-330ZH Zytel system could interfere with satellite navigation and cause drones to drift from planned routes. A weapon relying only on GPS coordinates might miss a moving truck or strike empty ground. Terminal control offered a partial answer. Even if navigation became unreliable, an operator could identify fuel tankers, ammunition trucks, or rocket carriers visually and guide the aircraft toward a vehicle. Communication links could still be disrupted, and operators had only seconds to correct the flight path. However, the method reduced Ukraine's dependence on one navigation source during the most important stage. The operation sought to force Russian air defense into a decision with no satisfactory outcome. If Pantsir and Tor continued concentrating on the bridge group, the convoy received less protection. If crews shifted radar attention and missiles toward the vehicles, more bridge drones could reach the crossing. This was not simple numerical saturation. The formations attacked different target types, arrived on different bearings, and demanded different priorities. The bridge represented continued movement through Armyansk. The convoy carried fuel, ammunition, drones, power equipment, and supplies needed farther north. Russia could not afford to lose either one. The pressure came from limited time rather than absent defenses. Russian crews still had functioning radars, missiles, guns, and electronic warfare. Yet those assets had to be assigned while targets closed distance. Changing attention from one direction to another consumed seconds and risked leaving gaps in both sectors. This sequencing also complicated command coordination, because each new track demanded rapid classification, assignment, and engagement under intense pressure simultaneously. By the time Russian crews began shifting sensors and weapons between the groups, the surviving drones needed only a brief final window. The forced choice had already shaped the battle. The next moments would determine whether that dilemma became irreversible destruction. The final phase began when 3 Ukrainian drones reached points on the Armyansk crossing. One struck near the entrance joint, another hit the central roadway, and a third damaged the connection on the far side. The impacts attacked different parts of the structure, reducing the chance that traffic could continue through a surviving lane. Once the crossing became unusable, the lead vehicles could no longer move forward. Trucks farther back were packed too closely to reverse or turn around. The 2-lane road, which had concentrated the convoy before the attack, now prevented an orderly escape. Drivers faced blocked movement ahead, burning vehicles inside the column, and incoming drones approaching from above. This created a physical lock. Even trucks that had not been hit directly were trapped by the collapsed route and damaged vehicles blocking the roadway. The convoy stopped functioning as a transport formation and became a stationary group of exposed targets. 5 other drones then struck dangerous cargo inside the convoy. 2 hit fuel tankers. Another targeted a truck carrying 152mm artillery ammunition. A 4th struck a vehicle loaded with Grad rockets, while the 5th hit a drone support truck reportedly carrying lithium batteries and fuel for generators. The first impacts created several hazards at once. Fuel spread across the road and carried fire beneath nearby vehicles. Artillery shells began exploding after a delay as heat reached the ammunition. Grad rockets ignited in bursts, sending flames and fragments through the column. Lithium batteries added fires that were difficult to control and could reignite after appearing to weaken. These effects multiplied the damage beyond the 5 vehicles struck directly. Heat, blast pressure, and fragments reached nearby trucks, while burning fuel connected separate fires along the road. According to the source material, about 10 vehicles caught fire. The remaining trucks were not necessarily destroyed, but many were no longer useful for the mission. The bridge ahead had failed, the center of the convoy was blocked, and ammunition continued detonating around the formation. As explosions moved through the line, the operation's result became larger than the number of vehicles lost. 2 crossings had been removed, while the surviving convoy was stranded. The outcome showed how timed strikes could turn limited direct hits into logistical collapse. The 2 strikes formed one operational chain. Chonhar was removed, Russian traffic shifted, vehicles concentrated near Armyansk, and the bridge and convoy were attacked together. Russia did not fail because it ignored the threat. It failed because its response followed logistical logic, and Ukraine appears to have anticipated that response. Russian defenses destroyed 18 of the 32 drones used across both waves. Yet the important targets were lost. That makes the interception rate less meaningful unless measured against the mission outcome. The deeper value of the operation was not simply the number of drones that survived or vehicles that burned. It was the ability to use one strike to influence where the enemy would have to appear next. Russia can repair bridges, open detours, deploy temporary crossings, or strengthen air defenses. But every solution may create another predictable bottleneck for Ukraine to observe and exploit. If you found this analysis valuable, please like the video, subscribe, and share it with others who want to better understand today's conflicts. We believe studying war is not about celebrating violence, but about understanding the decisions, strategies, and consequences that shape our world. The more we learn from history and today's conflicts, the better we can appreciate the value of peace and the importance of preventing future wars.